Start this recording here. All right. So start a new, oh, hold up. Stat 121. I think I've said it before, but I'm usually really sad on the last day of classes because I don't get to see you guys anymore. But I feel like I had to deal with that earlier, so now I'm just kind of excited. It's the last day of of classes tomorrow. So so today we're gonna do our I don't need to say stats, I put it there. Final exam review day. So like I said, I said just gonna hang tight. I'll let you guys know what it's gonna look like and all that fun stuff today. So that's what we're doing. First things first, for your test weight, right, which is 40% of your grade, what I decided to do, because I looked at it and I was trying to figure out what might be fair, and then I just decided to use your highest test score for your test weight. So I'll essentially drop your lowest one because there were people who did better on test 1, even though most people did better on test 2, right? There were some people who did better on test 1, so I just don't want to penalize that. So I will drop the lower of your 2 test weights, or your 2 tests, right? So whichever one was better for you, that'll make up 40% of your grade. So hopefully everyone's pretty happy about that. Aiming to please here. And because you guys had that test 2 sprung on you, so if that one was better, then I think that's pretty good. This guy says woohoo. I know, fun, right? So like I said, hopefully that's good news. Well, I don't see how it could be bad news. So there. All right. So so we got together on Monday afternoon and figured out what the final exam would actually look like. And so what we've landed on is using a Moodle quiz. They will have random numbers, all of them. So, but what you're going to do is you're going to write your work down on a piece of paper. So for the final exam, so format for the final exam. Questions will be in a Moodle quiz. Okay, so, and then of course you will be answering questions, and so answers I guess I should say you submit your answers. You submit your answers in the Moodle quiz. So there will be spaces for you to fill in the blanks. Typically, you know, you do a calculation, you draw your conclusions. So a lot of the work will be in the Moodle quiz, but then because we want to make sure that you're actually doing this stuff right, once you have done all the questions, once you have finished all the questions, okay, scan your test. And here, you guys, I know you know how to do this, but there's a surprising amount of people who say, I don't have a scanner, how am I supposed to do that? Download a free app to your phone, and there's lots of options. If you're not sure of an option, I've tried a couple. Which was the one that I have an iPhone, but the one that I liked, oh, Ruben says cam scanner is good, so some options here. Cam scanner, oops, I didn't write that very well. Cam scanner, I like Scannable, was really quick, but that's for iPhone. Cam scanner I think is for everyone, so oh, thanks Ruben, hang on, Ruben's got all kinds of tips and tricks here. Cam scanner is good. Oh yeah, so the Notes app in iPhone, I actually had a hard time finding the PDF, but maybe I'm just old. And then cam scanner is super easy and nice, cool. So you've got options, you can kind of figure it out. Maybe do a test run before the test, right? Because you will have to upload your work, right? So once you're finished all the questions, scan your test, right? And then upload your work as a PDF. So it has to be a PDF, and we're gonna upload to Moodle. Oh. Dun, 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 dun. Speaking of test run, is there going to be a practice final? I did post a review document, and we'll go through it later. I posted this document, which is just, I called it practice for the final, because it's way longer than the practice final. And then I'll post the practice final. To be quite honest, I don't like the practice final that much. I'd rather that you work through these more comprehensive problems, because it kind of, I don't know, I don't love it. Oh, Ruben says he hadn't seen that. That's all right. So, so you're gonna upload your work as a PDF. So you're gonna upload to Moodle, and just anticipating. No, I saw Sky's question. How do I upload? Where do I upload? Let's see here. How do you upload to Moodle? Only ever sent email to yourself is easiest to find. Oh yeah, you bet. There's for Brianna. Okay, so what I'm gonna do is I'm gonna make a Dropbox. So just how you've been submitting your Excel sheet for the lab to open, right? Now it won't be to open the test, it'll be just so that you can submit it for part marks. Awesome, thanks, Brianna. So upload your work as a PDF, upload to a Moodle Dropbox. Upload to, I'll say the Moodle Dropbox. Which is not created yet, but you'll see it. Let me just get caught up here. Okay. So you're going to upload your work as a PDF, because I think Moodle can only handle one file or something, and so I want it as a PDF. And to get a little bit more picky, use a new page for each question. All right. So question 1 might span 2 pages, but then on the 3rd page, I want question 2, even if it's, you know, a lot of page left on the 2nd page, I still want it on a new page. And that's just for me to be able to mark it quickly. So what I'll say here is that both the Moodle quiz, oh, I always do that. I always want to combine 2 words, especially when it's both. Both the Moodle quiz and your uploaded work will count as your final exam grade. Okay. So, so I'm thinking roughly the Moodle quiz might be about, I want to say about 60% of your grade. Written work, about 40%. Okay, so about a 60-40 split. This is of course subject to change because we're just creating the actual Moodle quiz right now, and then we'll see what happens. Okay, so even if you get the Moodle quiz answer wrong, right, you'll be able to recuperate and get part marks here in your written work. So I know that's pretty weird, but are there any questions? But that's what we're doing because it's weird times. No questions. Okay. Okay. So I didn't see any questions. So what I want to do next is just give an outline of the questions that you can expect on the final, right? And I will kind of keep some tricks up my sleeve, but what I want you to remember is that you are doing this thing at home. You're not going to work together because that's way too easy for me to spot. So you will have to work alone, of course. Otherwise, it's plagiarism. But besides that, you have all your resources. And so you will be working at home, right? So I want you to use all your resources, right? Don't try to be a hero here and say, oh no, I'm not going to use my notes. I'm assuming that you're going to have all your notes. I'm assuming that you're going to be able to look stuff up and just kind of have memory guides and all that kind of fun stuff. So so just use that, okay? It will be under a kind of a time limit, right? So you'll have the 3 hours. So the final exam, in case you missed it, final exams are still going to be held during the same time that they were scheduled. So the final exam is on April 21st at 9, well, and I guess 9 to 12. Okay, so that's when our final exam time is. So that is your final exam slot, and that's the one that we're using. So at 9 on April 21st, the final exam Moodle quiz will be made available, and then it'll close at 12. Right? And then you'll have a little bit of buffer time after that to upload your work. Okay. And then I'll say plus time after to upload your work. Hopefully, if you've practiced beforehand, kind of saving as a PDF and stuff, this part, you know, I'll give you about 15 minutes or so. I don't think that you should need anything more than that, so about 15 minutes. Okay. Let's see. Yeah, I see Brianna had a question. Oops. Oh yeah, so I will be in the Zoom room. So during the exam, I will be in the Zoom room. If you have questions. Yeah. But you'll have to use your microphone because I've done this a couple of times because I've had a couple of tests since we closed down. So so then I'm just in the Zoom room, but usually it's just kind of off to the side. So you will have to use your microphone. Have to use your microphone to get my attention. Because I'll probably not be sitting right there for 3 hours. I know you're sitting right there for 3 hours. Hey, my smiley's not cooperating. There we go. Oh, this looks weird. There. So if you use your microphone, then you can just kind of wave me down, so to speak, and then you'll be able to ask questions. What's kind of nice is if you just have the Zoom room kind of open to the side, I don't know, you know, your internet abilities, but presumably it would be fine to just have it open, and then in that case, if someone asks a question, then you can benefit from that too. So, or if you find that it's too distracting, then you can just log in if you have a question. But just know that I'll be there if you do have a question. Okay. What else did I want to say? So here, good, I've talked about that. And I've talked about that. Okay. So let's talk about the different, so the questions to expect for, so the final exam format now, did I say, I'll call it format there, okay. Final exam questions. Oops, it's all jumping around today. Questions to expect. All right. So the first question is going to be a regression question. We saw that on test 1. It's a very similar, and you can use your test 1 practice and your test 1, your actual test 1, which I've handed back, and the solutions are all posted on Moodle. So to both the tests, right? So when I refer to these tests, then you'll have lots of materials. The second question is a probability question with a contingency table. Probability question with a contingency table. That was also on test 1. Question 3 is going to be a tree diagram. So of course, some of these, right, will be more more in your written work, right? Making a tree diagram, you're not going to be able to do that in a Moodle quiz, but you will be able to answer the questions, right? So this would be a situation where maybe your work is worth a little bit more than your Moodle answers, right? So that's what I mean by, so the Moodle quiz will be roughly 60% of the grade and roughly 40%. It totally depends on, you know, what we're able to put into the Moodle quiz and what we'll have to mark as written work. So tree diagram you also saw on test 2, sorry, test 1. Said also, but then a different test. Question 4 is going to be a binomial question. Which you saw on, was that test 1 as well, I think? Test, I'm pretty sure. Correct me if I'm wrong. So you're not saying it's, yeah, I think you're right. Let me just check here. I think it's test 2 as well, now that I'm thinking about it. Oh yeah, because it was 6 and 7. Yeah. Okay, thank you. Thanks, Nina. Wrong page. Here we go. So the binomials from test 2, and yeah, that makes more sense. And there's going to be a Z-score question. No Poisson. Everyone's happy about that, I'm sure. Although I think once you get the hang of Poisson, it's really not that bad, right? So, and then a Z-score question, which was also on test 2. Okay. And then 1, 2, 3, 4, 5. And then 5 of the following. Okay. So only 5. We're going to list a couple more here. I'll list them alphabetically now instead. So what I'm going to do is we're going to essentially go through the formula sheet, right? And outline all the different types of hypothesis testing and confidence interval questions that we could have, right? And so there's going to be 5 questions from here, right? So the first possibility is one sample mean sigma known, right? That was your Z-score, and we did see that on test 2, right? And both hypothesis testing, oh, you know what, I'm going to scoot this over here just so I can have more room. Hypothesis testing and confidence intervals, right? So I use HT for hypothesis testing and CI for confidence intervals. Hopefully everyone's okay with that. And I'll just write it bigger here. That is from test 2, right? So you did both of those. In fact, you also did a sample size calculation. But I'm going to tell you that we're not going to use the sample size calculation from one sample mean sigma known. If anything, it would be from the proportion version that we did later on. We'll get to that though. The second option is one sample mean sigma unknown, both the hypothesis test and a confidence interval. In fact, I'm gonna give you guys a heads up here. if we do choose that one, it would be a confidence interval that you use for a hypothesis test, right? And so we've seen a couple of those options. So you would build a confidence interval, and then it would tell you, okay, use the confidence interval to test this hypothesis, right? And so that's how that one would go, probably. Well, if you get that one, that's how it would go. Next option is matched pairs. Hypothesis test or confidence interval. And so it would just be one of those. So not both. D is 2 independent sample means. And it would be a hypothesis test and a confidence interval, right? Sounds like a lot of work, but for the confidence interval, you've done a lot of the calculations in your hypothesis test already, right? And so just recycle all that work, right? Don't redo that huge square root. And once you do more practice, you'll know what I mean. And so 2 independent sample means, a hypothesis test and a confidence interval. The E-th option would be a 1 sample proportion confidence interval and sample size calculation. Okay, so those two are going to go together as one question, right? Or the other option is a 1 sample proportion hypothesis test. What's nice about proportion questions, right? We just saw those in chapter 9, these proportion questions, but for proportions, you don't need to know things like the mean and the standard deviation, right? You just need to know how many successes out of how many, your total sample size, and then you have all the information that you need, right? And so once you get familiar with the proportion questions, I think you'll find that they're quite a bit easier than means questions, but that's why we start here. So, or we can talk about 2 sample proportions, and it would be a hypothesis test and a confidence interval. Yuck. Especially because you have to check your conditions, right? So for E, F, and G, for E, oh, you know what? For E, F, and G, don't forget to check the assumptions. So there's how many? 1, 2, 3, 4, 5, 6, 7 options, and it's going to be 5 of these, right? So only 2 of these were cut, and just be prepared for all of them, right? Being prepared for all of these 7 isn't going to be that different from just being prepared for 5. So and like I said, right, maybe it's a good idea because you're working at home, right, as preparation for your for the final exam, right? Why not go through and outline kind of typical examples of each of these? And then the tricky part, and it always is the tricky part, is trying to figure out what type of question you have, right? So when you're reading all these questions, knowing that it's, well, a regression question is easy to pick out, right? But knowing that you have to use a binomial, right, that's going to be helpful, right? In fact, critical, right? That you know how to identify all of these problems, right? And then you can kind of knock them off the docket here. And especially once you get into hypothesis testing and confidence intervals, that's when it's going to be super important to be able to figure out what type of question you have, because once you know the type of question that you have, you'll know where to go on your formula sheet, right? If you decided you have to do a confidence interval, there's actually no confidence interval here for the matched pairs, because the matched pairs is essentially a one sample mean sigma unknown. Sorry, I see Hannah has a question here. Hang on. Yes. Yes. Good. So because I don't like to throw you off your game too much, these questions will be in this order, right? And so that'll help, unless there's like a spacing issue, but there shouldn't really be, or you know, kind of a reference issue, but there shouldn't be a problem in a Moodle quiz, so I'm not too worried about that. And then the last 5, right, they can be all kind of mixed up. Okay, so like I said, the hardest part will be to figure out what type of question you have, will be to figure out what type, oops, what type of question you have. Okay. So what I want to do now is I want to go through that practice document. So hopefully you had a chance to look at it. I think I posted it Monday afternoon, so you've had a little bit of time. But what I said was a really good exercise is just to go through each of those questions, and without even doing anything, right, figure out what type of question you have, because that's going to point you in the right direction on your formula sheet. And so using the practice for the final exam questions, we will go through and identify which type of question kind of doesn't make sense, but each question is. So to have it all in this document, what I'm going to do is I'm going to just copy paste each of these questions. Okay. And there are solutions to each of these, right? So here, I'll just make some room here. Solutions to the questions are posted on Moodle. Oops. Okay. So a startup company is about to market a new computer printer. A computer printer. It decides to gamble by running commercials during the Super Bowl. The company hopes that name recognition will be worth the high cost of the ads. The goal of the company is that over 60% of the public recognize its brand name and associate it with computer equipment. The day after the game, a pollster contacts 420 randomly chosen adults and finds that 263 of them know that this company manufactures printers. Would you recommend that the company continue to advertise during the Super Bowl? Right? So here, some key things to look out for, right? The first one being, I don't have a mean, I don't have a standard deviation. I'm given a proportion, a percentage is a proportion, right? And so here I suspect that it might be a proportion question, but also because I'm given the 263 out of 420, that seals the deal for me. Right now I have the sample proportion, and so the type of question here is, well, I only have the one sample of 420 randomly chosen adults, so I only have the one sample proportion, and I want to probably compare it to 60% or 0.6. So this is a one sample proportion question. And kind of guides you through, right? Check the assumptions. The assumptions depend on if I'm doing a hypothesis test or a confidence interval. So I read on, test with a formal hypothesis test, right? So I am doing a hypothesis test and a confidence interval, right? So I'm doing both. This is a hypothesis test and a confidence interval, right? So it's just giving you practice for all of this, right? Remember, for one sample proportion, your options were actually just a confidence interval and a sample size calculation. I'm not sure I have an example of that in this practice test because I just stole it from last year. Maybe later on, I don't remember. But it does go through the confidence interval and the hypothesis test. So that's question one. So some key things that we looked out for was the sample proportion. So p hat is 263 out of 420. Okay. How about question two? So an accounting firm is trying to decide between IT training conducted in-house and the use of third-party consultants. To get some preliminary cost data, each type of training was implemented at two of the firm's offices located in different cities. The table shows the average annual training cost per employee at each location. Are the mean costs significantly different? So a dead giveaway is this table of information, right? Even if we didn't have this table of information, we could still probably arrive at that we have two independent samples, right? Because each type of training was implemented at two of the firm's offices located in different cities. So they're not matched pairs, right? They're just two independent samples. And we want to know, are the mean costs significantly different, right? So here we're talking about two independent sample means. So the type here is two independent sample means. And then it looks like we're doing a hypothesis test and a confidence interval, right? So here you're doing both. Hypothesis test and a confidence interval, which I think was the exact same scenario. Yeah. So something like that. You can ignore the points because those will be adjusted, but roughly, right? It'll be roughly that. Okay, so like I said, a dead giveaway is when I have the mean and the standard deviation for two separate groups, especially if the sample sizes are different, right? So that would be an important thing to look out for, right? A lot of the time the sample sizes are the same, even if they are independent samples, but just remember for matched pairs, you would have to have an additional line of the difference between the in-house and the consultants, right? And then you would look at the sample size for the differences, the mean of the differences and the standard deviation of the differences, right? And so, so I think that these, especially if you have a table like this, they're pretty easy to spot the two independent sample means. Let's see here. Okay. So question 3, or I should just check for questions first, but I don't think there were any. No, not yet. So question 3 says that a mail order company has 2 warehouses, one on the West Coast, one on the West Coast. That typo should have been on the East Coast. The East Coast. And the second on the East Coast. The company's policy is to mail all orders placed with it within 72 hours. The company's quality control department checks quite often whether or not this policy is maintained at the 2 warehouses. A recently taken sample of 400 orders placed with the warehouse in the West Coast showed that 364 of them were mailed within 72 hours. Right, so here I've got a sample proportion, 364 out of 400 for the West Coast. And then another sample of 300 orders were placed with the warehouse on the East Coast, showed that 279, right? So now I have a sample proportion from the East Coast, 279 out of 300. Can you conclude that the proportion of all orders placed at the warehouse on the West Coast that are mailed within 72 hours is lower than the corresponding proportion for the warehouse on the East Coast, right? And so one dead giveaway, besides the actual proportions in here, is the word proportion, right? So often if it's a proportion question, well, there will be things like, it'll ask, are the assumptions for inference satisfied, right? But also it'll have the word proportion in there, whereas what we saw here, right, are the mean costs significantly different? So that's how I know it's a means question. So for the type here, I'm looking at 2 sample proportions. 2 sample proportions. And it looks like, so are the assumptions for inference, and then test using a 98% confidence interval. So we're going to build a confidence interval. And then for this, I think we should just use the confidence interval to see if the number of orders shipped on time is less for the West Coast than the East Coast. So I'll say this is a confidence interval to do some sort of hypothesis test. Right? That's not exactly what we had on our list of questions, right? For the 2 sample proportion, you'll have to do a hypothesis test and a confidence interval. But you could just do the hypothesis test here. You don't need me to tell you to ask you the question, right? The question here, can you conclude that the proportion of all orders placed at the warehouse on the West Coast that are mailed within 72 hours is lower than the corresponding proportion for the warehouse on the East Coast that is a hypothesis testing question, right? And so you could just go ahead and do the hypothesis test. Okay. Oh, question 4. I'll break it up here. It's across the page. Paste. What are we looking at here? You know what? I'll make this a little bit smaller so I can put the type on the same page. So here, a government agency has 6,000 employees. As an alternative to the traditional 5-day work week, employees were asked whether they preferred a 4-day work week at 10 hours per day, right? Or flexible hours. The table below shows the results by age category. So if you're under 30, the number of people who voted for a 4-day work week was 600 and flex hours was 300, right? So here we could find the marginal total of 900 out of these 6,000 employees were under 30, right? And so we could go on and figure out some probabilities here. This is a contingency table, right? So this is a contingency table, all right? And we can use it to figure out these probabilities. What's the probability? What's the probability? Probability, probability. So here, the type that we're looking at here is a probability question. Probability question with a contingency table. And so that would be question 2 on your final. Question 5. Oops. During an angiogram, heart problems can be examined via a small tube, a catheter, threaded into the heart from a vein in the patient's leg. It's important that the company that manufactures the catheter maintains a catheter diameter of 2.00 millimeters. Yes, please. Each day, a quality control personnel makes several measurements, and today they found that 50 randomly selected catheters they measured had a mean diameter of 2.0001 millimeters with a standard deviation of 0.0003 millimeters. If they discover a problem, they'll need to stop the manufacturing process until it's corrected. Do they need to stop the manufacturing process today? Right, so here they've collected a random sample of 50 catheters. They found the mean and the standard deviation of this one sample, right? So now remember we have 2 options because we're talking about. So for our type, we know we have a 1 sample mean, right? Because we've got just the 1 sample of 50 catheters. We found the mean and the standard deviation, so I know it's a 1 sample means problem. The problem is, where did the standard deviation come from? Right? Did it come from the population, because then sigma is known? Or did it come from the sample, which it looks like it did, right? So they found the 50 randomly selected catheters they measured had a mean of this and a standard deviation of this, right? So here, this standard deviation came from the sample, and so standard deviation from the sample, so that means sigma is unknown, right? Sigma is the population standard deviation, so this is a 1 sample mean, sigma unknown. And it looks like test using a formal hypothesis test and test using a 99% confidence interval. So here we're essentially doing a hypothesis test and a confidence interval. Okay, so that's the tricky part right now, because we've got, instead of test 2 where we knew it was going to be sigma known, right now we can have the option where sigma is unknown, which is actually more common. Oh yeah, this question, when I typed it up, because of course I don't make these things up, I steal them from textbooks and, you know, whatever sources I find. And the question, so in a group of college students, some like iced tea, so I call it iced tea like I wrote here, but I'm pretty sure the question in the textbook, and this is off track, but anyways, just call it iced, so no D, tea, iced tea, and it sparked some debate in the office if it should be iced tea or iced tea. It doesn't matter, but just so you know. So in a group of college students, oh, let's see, how has a question here. Okay, so if you choose the wrong type of question, right, you can still get part marks in your written work if you follow through, but I mean, the answers that you enter in Moodle just wouldn't make sense, right? So those would be wrong, but then your written work, as long as you follow through, it would be considered, you know, reasonable. Right. But it should be pretty hard to pick the wrong answer or pick the wrong type, right? Like you want to make sure that you have the right type before you go ahead and do it. Good. All right, so back to the iced tea. So in a group of college students, some like iced tea and others do not. There's no student in this group who is indifferent or has no opinion. The probability that a randomly selected student likes iced tea is 0.84. 2 students are randomly selected from this group. Build a tree diagram, labeling all the appropriate probabilities. What's the probability? What's the probability? What's the probability? This is obviously a tree diagram question. So tree diagram. Okay. So, and you do have to do that in question 3 on the final. All right. So let's see here. What's the next question? Oops. So the next question that we're looking at, an ergonomics consultant is engaged by a large consumer products company to see what it can do to increase productivity. The consultant recommends an employee athlete program encouraging every employee to devote 5 minutes an hour to physical activity. The company worries that the gains in productivity will be offset by the loss in time on the job. Management would like to know if the program increases or decreases productivity. To measure it, the company monitors a random sample of 145 employees who word process, measuring their hourly keystrokes both before and after the program is instituted. Here are the data. Wait, is there no data? Oh, here. I just didn't go to the next page. Whee! That makes more sense. So it means, here are the data. Is there evidence to suggest that the program increases productivity? Right, and so here, one key thing that catches my eye right away is that I have a difference column, right? Or I have the differences. In fact, I have the mean of the differences, the standard deviation of the differences, and the sample size of the differences. So this tells me that I'm talking matched pairs, right? But also because They took a random sample of 145 employees who word process, measuring their hourly keystrokes before and after the program is instituted. So here, right, this is matched pairs for a couple of reasons. So type, this is going to be matched pairs since two measurements, right, before and after, are being made on the same individual. Since two measurements are made on the same individual. And it looks like we're going to do a formal hypothesis test and build a confidence interval. All right, so this is a hypothesis test and a confidence interval. This is made. Okay. So one thing, right, if I have the mean and the standard deviation for the differences, I know it's going to be matched pairs, but also I can back it up and say, okay, well, I need to make sure that there's been two measurements that are made on the same individual, or in this case, you would even consider things like twins to be the same individual, right? Because you can eliminate a lot of the variability that way. But for us, we'll stick to just the same individual. Okay. You guys have to look past all my typos in here. The amount of time Facebook users spend on the website each month are normally distributed with a mean of 6.7 hours and a standard deviation of 1.8 hours. Find the probability that a Facebook user spends less than 4 hours on the website in a month. How long do the top 10% of Facebook users spend on the website per month? Now you take a random sample of 45 Facebook users. What's the sampling distribution of X bar? What's the probability that the sample size, that a sample of this size spend more than 10 hours on Facebook in a month on average? Here's kind of the telltale. So blah, blah, blah follows a normal distribution. So we're normally distributed with a mean of this and a standard deviation of this. That's how I know this is a Z-score question. So the type that I'm looking at here is a Z-score question. So it does have a lot of different components, right? So the probability, the sampling distribution, and then a probability again, but we're talking about the average instead of one user. Nine, you won't actually have on your final, right? Because it's not on the list, but we can talk about the type. So here, the ages of 15 college professors is given below. And then, so it's got 15 data points, right? For extra practice, you can do it with 9, 10, or 11 entries, or however many, right? But there's no solutions for that. There's solutions for the 5-number summary and then finding if there's any outliers. This is the type of stuff that you did on the lab final. So this is not on the, oops, on the final. But if I had to call this a type, I would call it a 5-number summary question. I'll just put in here, not on the final. You're running a political campaign and wish to estimate with 95% confidence the population proportion, so already you know that this is proportion related, of registered voters who will vote for your candidate. Your estimate must be accurate to within 3% of the population proportion. Find the minimum sample size needed. So this is a sample size calculation for the proportion, right, for one sample proportion. So here, the type is one sample proportion sample size calculation. And that's the one that you have to, you do have to do on the final, right? But we said that it's going to be together with the confidence interval, right? So if you have to do a one sample proportion confidence interval and a sample size calculation, right? So it's not just going to be a standalone sample size calculation, it's going to be a confidence interval as well as a sample size calculation, kind of parts A and B. Right. But here they're split up a little bit differently, but let's give you more practice. So question 11 spans this page, so I'll just copy, paste all of it here. Oh, blah. Just to keep it on the same page, I'm just going to make these questions because we're not actually doing them, but I want to have them on here. Kind of like that. Still legible, but I want it on the same page. So here, telltale sign, without even reading anything here, if I'm given a scatter plot, I know it's going to be a regression question, right? And so already I know this is a regression question, and we'll just confirm it, right? So if you go ahead and read the parts, we'll describe the relationship, what's the slope, interpret the slope, what's the intercept, interpret the intercept, what's the equation, right? And so here, kind of a, oops, trying to stay on this one line here. The type of question here, oops, is a regression question. Okay. What we'll see, because there's another regression example here that I'll also cut and paste in. Looks like this. Oh. I guess this one I have room for. Notice that it goes % of returning birds. I didn't give it enough room for that image, but that's okay. And then okay. This question is also a regression question, right? So I'll make a note here, right? I know this is a regression question. The difference is that in this blurb, right, one of nature's patterns connects the % of adult birds in a colony that returned from the previous year and the number of new adults that join the colony. You examine 13 colonies of sparrowhawks. describe the relationship between the count of new adults and the percent of returning birds. There's no information on the mean or the standard deviation of y, or the mean and the standard deviation of x, right? But you are given essentially the r squared, right? So here, this type is different from this type of regression question, because here, right, you're given the mean of the number of votes registered was 736.9, right? So mean of x is 736.9. The standard deviation of x is 189. The mean number of manatees killed was 52.1, so that's the mean of y, and the standard deviation of y is 25.7, and the correlation. So here you're given the correlation. Given x bar, y bar, sx, sy, and r. Right. Whereas this is also, and I'll do the same thing here, this makes it a regression question, but a lot of other things too, but the plot is a dead giveaway. Here, the type is also a regression question. But instead, we're given r squared. Right, so you're given r squared, and you're given the regression equation. Given r squared and y hat equals a plus, or sorry, I'll just use the same setup. Do we use a and b in no, b not b1. Y hat is b naught plus b1x. Right, so this information that you're given can go two ways. Right? Most likely it'll be this, right? But you need to be prepared for this situation as well. Okay. So I think those are all the questions in that practice for the final document, right? And like I said, the solutions are posted. And let's just make sure that I didn't miss anything here. I think there's no binomial question, right? So we talked about there's a regression question we've seen, a probability question with a contingency table we've seen on there. We had a tree diagram. The binomial, I don't think we had a binomial question on here, did we? Let's put that at the bottom here. So the practice is missing binomial. This is more for me than for you. I'll add it. But let's see here. Read those questions. But you've got most of them. So it's missing a binomial, so I'll add that and update it. We had a Z-score question. I don't know if there was a one sample mean sigma known question, right? Those are kind of weird. So, but you did have some on test 2, so I'll put that on the list as well. Copy. What else was missing here? Although I might just not remember. One sample mean sigma unknown, I know we had. Not necessarily going from a confidence interval to a hypothesis test, but you can definitely do that. We saw matched pairs. Pretty sure it was hypothesis testing and confidence interval, so you're all covered. 2 independent sample means we saw, and I'm pretty sure I made you do a hypothesis test and a confidence interval, so that's good. We saw the one sample proportion confidence interval and the sample size calculation. They were separate, but but that's all right. All right. Still saw both of these for practice. One sample proportion hypothesis test. I'm not sure we saw explicitly. Can't remember now, but because there were a lot of questions here. Oh yeah, we did the first one. Good. So we saw one sample proportion hypothesis test, and we also saw two sample proportion hypothesis test and confidence interval. So the only two that are really missing from here are the binomial and the one sample mean sigma known, which you've had practice from test 2 on. So I'm not leaving you high and dry. Are there any questions? We'll go to the any questions? Because that's it. That's all I've got. As per usual, no time to do any actual questions, but that's why I have the solutions on Moodle already. Okay. See who's all here. Nice. Thanks for coming, guys. All right. No questions? I know. Thanks, guys. I know. Thanks, guys. All right. So if you have any questions for the final, then just let me know. But otherwise, you're free and clear. All right. Gonna boot you all out. Even you, Emmanuel. I'll see you later. Bye, guys.